In this learning session, we'll be learning about polynomials. Now, what is a polynomial? A polynomial is an algebraic expression with the powers of the variables as whole numbers or positive integers. Remember that. Now, if you look at these examples, x plus 2 is a polynomial. The power of x is 1, which is a whole number, and x square plus 2x plus 3 is also a polynomial because the powers are whole numbers, and this is also a polynomial because the powers of the variables are integers or whole numbers. So remember the definition of polynomial. Now, what is degree of a polynomial? The highest power of the variable in any polynomial is the degree of that polynomial. For example, in this polynomial, the power of x is 1, therefore it is a first degree polynomial. In this, the highest power is 2, therefore it is a second degree polynomial. In this, the highest power is 3, and therefore it is a third degree polynomial. Please remember that. So the the highest power of the variable in any term of a polynomial decides the degree of a polynomial. Now, the types of polynomials. Types of polynomials can be classified on the basis of number of terms and on the basis of degree. On the basis of number of terms, we have got a monomial, binomial, trinomial, and so on, multinomial, etc. Wherein in a monomial there is only one term, only one algebraic term makes a monomial. If there are two terms, then it is a binomial. This is a trinomial. This is a tetranomial, and so on. That is on the basis of number of terms. And on the basis of degree, we have a linear polynomial. A polynomial of first degree is known as linear polynomial. If you look at this polynomial, the power is 1, therefore it's a linear polynomial because its degree is a first degree polynomial. A quadratic polynomial is a second degree polynomial. Here the degree of this polynomial, that is trinomial, is 2 or second degree, and therefore it is a quadratic polynomial. A polynomial of third degree is cubic polynomial. A polynomial of fourth degree is a biquadratic polynomial. A polynomial of nth degree is a polynomial of degree n. So remember that. Now, coming to the next point, that is 0 of a polynomial. Now, what is 0 of a polynomial? The value of the variable that makes the value of a polynomial 0 is called 0 of the polynomial. If p of x is a polynomial, and k is the value of x, which makes the value of the polynomial 0, then k is the 0 of the given polynomial. Please understand this very clearly. So the value of the variable that makes the value of the polynomial 0 is known as the 0 of the polynomial. Remember that. Now, let us understand how to find the zeros of a polynomial and also verify whether they are the zeros or not. Now, if you are given a polynomial px is equal to x square minus 3x minus 4, now we are asked to find the zeros. Remember, it is a second degree polynomial, and a second degree polynomial will have two zeros. Please remember, it will have two zeros. And to find out the zeros of this, we have to factorize it, find the factors of it. Now, it is a trinomial, so we can go for middle term splitting method. So 3x can be split as minus 4x plus x, and therefore the trinomial becomes a tetranomial, and we can group them, pair them, and then take HCF common and find the two factors, x minus 4 and x plus 1. Now here x minus 4 can be 0 and x plus 1 can be 0. If I take x minus 4 as 0, then x is equal to 4. If I take x plus 1 is equal to 0, x is equal to minus 1. Therefore the zeros of this trinomial given to us is that we have x is equal to 4 and x is equal to minus 1 are the zeros of the given polynomial. Now, to verify whether they are zeros or not, it is very simple. Now take px, that is x square minus 3x minus 4, and wherever x is there, replace by 4 and minus 1. So if I take k as 4, then it becomes p4. Wherever x is there, put 4. X square is 4 square, 3 into x is 3 into 4 minus 4, and simplify, will get p4 is equal to 0. So for pk, that is when k is 4, the value of px is 0, therefore k is equal to 4 is 100% the 0 of the polynomial. Same way, for k is equal to minus 1, p of minus 1 is equal to, wherever x is there, put minus 1. So minus 1 square minus 3 of minus 1 minus 4, that means 1 plus 3 minus 4, again it is 0. So when k is minus 1, that is pk is equal to 0, therefore px is the polynomial of which minus 1 is 0. Therefore we have verified that 4 and minus 1 are the zeros of the given polynomial. Now, what is a linear polynomial? Already we have learned this. A polynomial of first degree is called a linear polynomial. Now, px is equal to 2x plus 5. This is a first degree polynomial, and therefore it is a linear polynomial. Please remember that. Now what is the general form of a linear polynomial? The general form of a linear polynomial is p of x is equal to ax plus b, and here x is a variable of first degree, a is the coefficient of x, and b is a constant. So please remember the general form of a linear polynomial is p of x is equal to ax plus b. Now what is the zero of a linear polynomial? The zero of a linear polynomial is the value of the variable which makes the value of the polynomial 0. Now if k is the zero of the polynomial which makes the value of the polynomial 0, then pk must be equal to 0. If pk is equal to 0, that means ax plus b must be equal to 0, or ak is equal to minus b, or k is equal to minus b by a, and therefore k is equal to minus b by a is the zero of the polynomial. That means the value of x is equal to minus b by a, and that makes the value of the polynomial 0, and therefore x is equal to minus b by a is the zero of the linear polynomial. We can verify this. Now we have been given px is equal to x plus b, k is minus b by a, find pk. So wherever x is there, put minus b by a, we will find that it is 0, and therefore k is equal to minus b by a, or x is equal to minus b by a is 100% the zero of the given linear polynomial, that is p of x is equal to ax plus b. Now what is the relation between zeros and the coefficients of a linear polynomial? What is the relation between the zeros and the coefficients of a linear polynomial? Let us understand this. Now we are given a general polynomial, that is linear polynomial, that is px is equal to x plus b. That means ax plus b equal to 0. Please understand here, ax plus b equal to 0, because we want to find the zero of this. Therefore I have to remember one thing: to find the zero of this I have to equate this to 0, because the value of this has to be 0. So ax plus b equal to 0, ax is equal to minus b, x is equal to minus b by a is the zero of the given polynomial, or k is equal to minus b by a is the zero of the polynomial. That means k is equal to minus times b is the constant term, so constant term divided by coefficient of x. So therefore remember, if k is the 0 and k is equal to minus b by a, then k is equal to minus times constant term divided by coefficient of x. Zero of a linear polynomial is therefore given as the negative value of the ratio of the constant term to the coefficient of x. Therefore remember that k is equal to minus b by a is the zero of a linear polynomial, and k is equal to minus times constant term divided by the coefficient of x. A very important relation which you have to remember. So remember as to what is the zero of a linear polynomial and what is the relation between 0 and the coefficients of a linear. Now the geometrical representation of a linear polynomial. The graph of a linear polynomial is a straight line. If p of x is equal to ax plus b is a linear polynomial, then y is equal to ax plus b is a linear equation. If we draw the graph of this linear equation, then we get a straight line. So therefore remember, the geometrical representation of a linear polynomial is a straight line. Now, what is the geometrical meaning of 0 of a linear polynomial? If the graph of y is equal to x plus b is a straight line which cuts the x-axis in a point P, and the coordinates of point P are minus b by a and 0. Therefore, the x coordinate is minus b by a. But we know that minus b by a is the 0 of the polynomial p of x is equal to ax plus b. Therefore, k is equal to minus b by a is a 0 and is x coordinate of the point where the line cuts the x-axis. Therefore, the geometric meaning of 0 of a linear polynomial is very clear, that the 0 of a linear polynomial is the x coordinate of the point P where the graph of the polynomial cuts the x-axis. Therefore, 0 of a linear polynomial is a point on x-axis where the straight line graph of the polynomial cuts the x-axis. The graph cuts the axis in only one point. Therefore, px is equal to ax plus b, which is a linear polynomial, has only 1 0. Remember that. Now let us take an example to understand the geometrical meaning and the geometrical representation of a linear polynomial. If p of x is equal to 2x plus 3 is a linear polynomial, then y is equal to 2x plus 3 is a linear equation. Now when we draw the graph is a straight line. The graph is a straight line here which cuts the x-axis in one point P. And if we find the 0 of 2x plus 3, then the 0 of 2x plus 3 will be k is equal to minus b by a, that is minus 3 by 2. That means here we have the 0 of px is x is equal to minus 3 by 2, but minus 3 by 2 is the x coordinate of the point P where the graph of the polynomial px is equal to 2x plus 3 cuts the x-axis in point P. Now the 0 is k is equal to minus b by a. 0 is the x coordinate of the point where the straight line graph cuts the x-axis. The graph cuts the x-axis in only one point. Therefore, the linear polynomial has only 1 0. So remember this, that the 0 of the given polynomial px is equal to x plus 3 is k, that is minus b by a, that is minus 3 by 2. And the 0 of so now we know that 0 of p of x is x is equal to minus 3 by 2, but also it is the x coordinate of a point p where the graph of the polynomial, that is the straight line graph, cuts the x-axis. Therefore, it's very clear that the 0 is k, or 0 is minus k is minus b by a, it is minus 3 by 2, and also it is the x coordinate of the point p on the x-axis where the graph cuts the x-axis, and it is the only one point where the graph cuts the axis. Therefore, the 0 of a linear polynomial is only 1 0. That means linear polynomial has only 1 0.